Lesson 2-6, special functions. So in this section, we are going to be focusing on graphing. So I'm going to skip this part for just a second, and I would like you guys to take a look at these two problems, and I would like you to pause the video and graph them. All right, so remember when we are graphing, we need our equation to be in y equals. So if it's not in y equals, the first thing we would have to do is solve it for y. And then we would graph our y-intercept. So 1, 2, 3, 4. And then if my slope is 2/3, that means I'm going up 2 over 3. And then if I wanted to do it backwards, I could also go down 2, left 3. Okay. Now we only need 2 points to graph. But usually the more points we have, the straighter our line is going to be. Okay. All right, and then on problem 2, we should be starting at 1. And then since my slope is -2, I have to think of this as over 1. So from this point, I need to count down 2 and then right 1. And if I did it backwards, I would go up 2, left 1. And then I'm connecting those points together. Okay, so that's how we graph normally. Now, if I move this up a little bit to our next problems, if I add a phrasing like this, so if, and then this says x greater than or equal to -3, that means that I only want to graph the part of the graph where the x values are going to be bigger than -3. So this is the same equation as this top one. So if I'm graphing it for the x is bigger than -3, I would only graph this part. So what I'm doing is I'm creating an array. So when we have restrictions, we aren't going to have our normal lines. We are going to have some type of ray or a segment. And depending on how complex we could get, we could have a line with a hole or just a point. Okay, so those are all possible to happen when we are dealing with a restriction. So again, we would have something like our equation of y equals mx plus b, and then we would say if our x is greater than or equal to some number. Okay, so this part right here, this is the restriction. And it's always a restriction on the x values, so the domain part of our equation. Okay. So when we have one restriction like this, this is going to create the ray. Okay. Now, if I say if a number is less than x is less than or equal to another number, this is going to give us a segment. Okay, so that would mean that I am cutting off two sides of our graph, so we would only see this piece depending on what we're talking about. And then we'll talk about these two if we get to those examples. Okay, so for right now, I want you guys to focus on the ray and the segment part. Now, along with this, because we have cutoff points, we could have open or closed circles. So anytime we have the greater than or equal to or less than or equal to symbol, this is going to be a closed point. Okay. If it's greater than or less than, this is an open point. And with that, when we have when it's array, if it's the less than or equal to, it's going to go to the left. So I'm going to have array pointing to the left. And then if it's the greater than or equal to, that's going to go to the right. Okay. And then a segment is going to have 2 endpoints. All right, so again, ray should be something like this. And then a segment is going to have 2, this should be an open circle with how I wrote that, and then a closed point. Okay. All right, so we're just going to do some practice problems. Okay, so looking at problem 3, based on this restriction, I'm going to have an array. It's going to have a closed endpoint because of the bar underneath the inequality symbol. And when we're done, we should have an arrow pointing to the right because this is our greater than symbol. Okay? So there's a couple of different ways that we can approach graphing these problems. So I'm going to show you some different ways, and then you can choose the one that makes the most sense to you. So the first way that we can do this is we can just graph this equation like normal. So 1, 2, 3, 4, up 2 over 3. Now when we do it this way, we're going to want to put a lot of points on our graph, just because we might not be sure where it's going to be cut off. So I'm not going to connect the lines together, and I want to make sure if I'm using a pencil, and I'm going to be using this method, I'm going to be erasing, so I want to write lightly. So now what I'm going to do, since I have all my points on here from this graph, I'm going to find this value on the x-axis, and then I'm going to go up or down until I hit a point, and I'm going to make that a solid closed circle to show my endpoint. So 1, 2, 3, and then I have to go up until I reach my point, so I'm going to bold this. And then since it's greater than, that means I'm connecting my endpoint going to the right. So I'm going to connect it going this way. And then I would erase any of my extra points. Okay, so that's the erasing method if you would like to do it that way. Okay. Now the other way that we could approach this is by making T-charts. So when we make a T-chart, the first X value that we pick is always going to be whatever this number is. Okay, it doesn't matter what this symbol is, we have to pick this number. Okay. And then we pick our second number based on this symbol. So if this is the greater than symbol, then I need to pick a point bigger than -3. If it's the less than symbol, then we would pick a number smaller than that. Okay. And usually we can just go one away, but when we have a fraction, we want to add or subtract whatever this denominator number is, and that will ensure that we get a nice whole number when we start simplifying. So I need to pick a number bigger than -3. Since I have a fraction here, I'm just going to add 3 to this number. So -3 plus 3 is 0. And then to get the y values, we're going to substitute these in one at a time for the x. So as kind of side work, we're doing 2/3 times -3 plus 4, and then simplifying that. So 2 times -3 is -6. -6 divided by 3 is -2. And then -2 plus 4 is 2. So that's my y value that would go here. And then we would substitute 0 in. So 2/3 times 0 plus 4. So that just cancels out, and we are left with 4. Okay. And then as long as we're picking whatever this number is first, this is always going to be our endpoint. So I know that my endpoint has to be solid, so it might be helpful off to the side just to make a note of that we're going to have a solid endpoint. And then we would just graph those 2 points. So if I were to graph this, I'm going left 3 and then up 2. So here's my endpoint that I already have here. And then my next point, I'm at 0, and then I count up 4. So 1, 2, 3, 4, put my next point, and then we would just connect this together into that ray. So again, we can use our erasing method, or we can do the T-chart method. So I do not care which one you choose to use. Okay. So for me, I'm going to be using the T-chart method because that's the one I think is easier. So on this next one, again, I have a single restriction here, so I only have that one number, so that's going to give me an array. I don't have a bar underneath it, so that means that my endpoint is going to be an open circle. And then when I'm done graphing, I should have an array pointing to the left. And that's because of the less than symbol. Okay. So for my first x, I have to pick 2. And then since it's less than, I need to pick a number smaller than 2, so I'm going to pick 1. And then now we're just substituting it in for the x. So again, so if you can do this in your head, you don't have to write out the work. I just want to make sure you know where I'm getting this number from. So we're taking negative 2 times 2 plus 1. So that's negative 4 plus 1, which is negative 3. And then if I substitute the 1 in, negative 2 times 1 plus 1. So that will be negative 2 plus 1, which is negative 1. Okay, so now I'm ready to graph. So again, my endpoint's going to be open because there's no bar underneath this one. So right 2, down 3, open circle. And then your second point is always closed because it's on the graph. So I have to go right 1, down 1. And then we connect the endpoint to that second point. And again, just to double check that we did it right, I should have a ray going to the left. And I connected it to the left, so we did it correctly.